Welcome to my sunroom chat. Today I will discuss the properties of photons, the little particles of light. It's quite amazing that photons have been studied for more than 400 years. Sir Isaac Newton was the first to propose that light was composed of particles. Since that time, numerous studies have shown that Newton was correct. I'm sure Newton thought photons were composed of matter. However, according to Albert Einstein, photons are composed of pure energy. I wonder how the properties of pure energy compare to what we might expect if the photons are composed of matter. Let's keep track of these properties in a little chart. I will enter the first, that photons are particles.
I will list the observed properties of photons in the left column. Numerous experiments have shown that photons are particles. This means Einstein's photon energy substance behaves as though it is a particle. Of course, one might predict that a photon composed of matter would be a particle. I'll add this property to the right-hand column.
Maxwell provided the equation needed to calculate the momentum of a photon. By 1900, experiments carried out by several physicists demonstrated that photons have momentum.
Momentum of any object is equal to its weight times its velocity. This is spoken of as linear momentum. What the scientists demonstrated is clear. Photons have weight that can be measured in kilograms.
The weight in kilograms exactly matched what was predicted by Maxwell's equations. And Maxwell's equations were derived with the understanding that photons are composed of matter.
Let's add linear momentum and weight to the list of properties. This means Einstein's photon energy substance has momentum and it has kilograms of weight. If photons are composed of matter, they should have weight and momentum. Let's add this to the right-hand column.
If photons have weight, then photons might have spin angular momentum. Earth spinning on its axis has great spin angular momentum. The photons also have been shown to have spin angular momentum. Once again, it must have weight, and it must spin on its axis.
Let's add these two properties to the list for Einstein's photon energy substance. And of course, if the photon is composed of matter, we can expect the spinning photon would have spin angular momentum.
Physicists have demonstrated that there is a gravitational force of attraction between photons and stars. Scientists call the entity that pulls the two objects together gravitons. Sir Isaac Newton realized that the gravitational force of attraction between two objects requires both of them to have weight. This is a requirement of the universal law of gravitation. It also requires that the photon is creating gravitons and a gravitational force field.
Let's add gravity and gravitons to the photon's list of properties. This means Einstein's photon energy substance creates a force of attraction with a star. Notice, in this situation, the photon's connecting links are made from energy, while the star's connecting links are made from matter. Does this seem reasonable, or even possible? In contrast, if the photon is composed of matter, then the connecting links are both made from matter. We can easily predict a force of attraction between photon and star.
Thus far, the photon has all the properties we might expect if photons are composed of matter, but there is more to come. I will continue with this analysis in my next sunroom chat. Thank you for listening. I encourage you to read my book,